You want answers?
I think I'm entitled.
You want answers?
I want the truth!
You can't handle the truth!
So NASA said there's going to be an ellipse during the eclipse. An ellipse can only work with a domed top. If you don't believe me, I'm going to need you to Google it. But an ellipse is focusing frequency off of one part of the dome very lightly, as if I was here standing beside you and I whispered to you.
Let's understand what exactly an ellipse is. How do we understand the shape of an ellipse? Suppose we have 2 points in a plane. We name this point as F1 and this point as F2. Now consider a special set of points on the same plane. They are placed such that their sum of the distances from these 2 points is constant. Let me explain. Suppose we take a point here. Let's name it A. Now let's say the sum of its distances from point F1 and point F2 is some number alpha. Now consider all such points whose sum of the distance from these 2 points is exactly equal to alpha. Are there any such points? Yes, there are many more. Collection of all such points is called an ellipse. Let's say we take a point B on the ellipse. Then the sum of its distances from the points F1 and F2 will be alpha. Let's take another point C here. Again, the sum of its distance from these 2 points will be alpha. So we see that the ellipse is a collection of all points in a plane such that their sum of distances from the 2 fixed points in the plane is constant. Each fixed point F1 and F2 is called the focus of the ellipse. And together they call the foci of the ellipse. Here we took the constant to be alpha. But we can take it any number for the constant sum of distances, with the only condition being that it should be greater than the distance between the foci of the ellipse. Now suppose we want the constant sum of distances to be beta. Let's say beta is greater than alpha. Then the set of points corresponding to this constant beta will be this ellipse. If we take the constant to be the number gamma, which is less than alpha, then the ellipse will look like this. Now let's look at one ellipse. An interesting thing happens when the 2 foci of the ellipse coincide. Can you guess? We get a circle. All the points will be at a distance of alpha over 2 from the center where the 2 foci coincide. So we see that a circle is a special case of an ellipse when the 2 foci of ellipse coincide. So now we know that for an ellipse, we need to know 2 things. First is the 2 fixed points called the foci of the ellipse, and second, the constant sum of the distances of the points on the ellipse from these foci. Then the ellipse is the collection of all the points whose sum of the distances from the foci is that constant. Now many of you may have a question from our example of the whispering gallery. Suppose you and your friends are in a whispering gallery with an elliptical shaped ceiling. How will you know where to stand to hear the whispers of each other? That is where the foci of the elliptical ceiling are.
Hearsay!
Bailiff,
Briefcase!
disregard.
In my chambers.
Stop beavering the witness.
Arrest.
We could totally be lawyers.
Bang.